Hello and welcome back. In this video, we'll begin working on writing our connection classes and try to send some game information to a connected client from our server so we can configure Pygame on the client end. So let's head over to the server script and begin. So if we look, we're already creating a connection object, my connection, all the way down here at the bottom of our script. So what we need to do is we actually should probably write this connection class right now. So our connection class is right here towards the top. We just have an initialization method. So let's fill in this initialization method as we start here. So the first thing that we'll do is we'll add some attributes to the connection class. In particular, I'll add I'll do I'll add an encoder, self.encoder, and I've been using UTF-8. And I will then set a header length. Now, in past videos, we've been using like that byte size constant. We're not going to do that here because we're not going to just set an arbitrary maximum byte size. Instead, we're going to use a fixed length header for every message packet that we send. We'll send the header first, which will have a fixed length of, say, 10, and it will indicate how big the next incoming package is going to be, and then we'll send it over. And so this is going to make things work so much better for us here using this new updated method. So we'll say self.header length is equal to 10. Awesome. Now what we'll do is let's create a socket for the connection class. So we'll say create a socket, bind, and listen. So we'll do self.server socket is equal to a socket.socket, and in here we'll pass socket.af_inet. There's IPv4, and we'll do socket.sockstream. There is our TCP connection. Next, let's bind it to a specific location. So we'll do self.server socket.bind, and where do we want to bind it? It's got to be a tuple. Well, we've got our host IP and host port right here, so let's set those values in. So we'll do host IP, comma host port. Wonderful. And now that the socket's created and it's at its location, we just got to listen. So we'll do self.server_socket.listen. Excellent, excellent, excellent. So while we're here on the script file, let's see what else we're doing right when we start our server. So let's scroll back down. So if I scroll back down here, we see we create a connection object. Perfect. We're also creating a game object. So why don't we go work on writing the game right now? And it's kind of great. We're actually feeding it the connection object that we just created, so that will work out really nicely. So let's go to our game class, and let's work on the game's initialization method. All right, so we'll get rid of pass. And here, the first thing that we'll do is we're passing in the connection object. So let's set that connection object as an attribute of our game class. So we'll say self.connection is equal to the connection object that we just passed in. Awesome. So now we can access that in any of these other methods. Let's also set some things that are going to help us sort of keep track of the game on the server end. For example, let's set a player count. So self.player count, and we'll initialize it to be 0 because right now nobody is connected to the game. Now we're going to, every time someone does connect to the game, if you recall, we're going to be creating player objects for each client that connects. So I want to keep track of these player objects. So I will have a list, self.player objects, and we'll initialize it as a blank list. And then I'm also going to keep track of all of the sockets that correspond to those specific players. So self.player socket. Sockets, I'll say, sockets plural. So when our first client connects, they'll get a player, it'll be at index 0, and then we'll have their socket at index 0. The next client connects, they'll get a player at index 1, and their socket at index 1. So that's going to, I think, correspond kind of nicely here. And lastly, I'll create an attribute round time, and we'll set it to our constant variable that we've defined up here, round time. And this is going to help us control how long a game takes from the server side. So if you remember, we're going to keep track of everything time-wise on the server and then push that out to all of our connected clients. So everyone's in sync, essentially. So we'll do self.round time is equal to that constant variable round time. All right, wonderful. So now that we can initialize instances of our connection class and our game class, we're going to try to call the game class's connect players method. That's the last thing we do down here to sort of start our server, right? We initialize our connection, we initialize our game, and now we're calling connect players. So let's try to write this method for our game class right now. So if we scroll up, we find connect players right here inside of our game class. All right, so let's talk about what we need to do in this method. So we're going to have a constantly running loop that is going to accept clients as they join the server. However, we don't want to accept all clients. We only want to accept clients as long as there's room in the game for them. So if you recall, we have a variable, constant variable, total players. So as long as the game's player count attribute, which is currently set to 0, as long as that player count is less than the total number of players we're expecting, we should just keep running this while loop, listening for incoming players. So we'll say only accept players if the player count is less than total players. So we'll say while self.playerCount is less than our total players constant, we'll accept incoming player socket connections. So when we call the accept method, if you recall, we are going to get two pieces of information. We'll get the player socket and the player address. So let's grab them. And I think in the past I've been calling them like client socket, client address, but here I'm going to call them player socket and player address just because, this is the nature of a game. So we'll say player socket and player address are equal to self.connection.server socket. So this is how we're going to access the server socket from inside of the game. The game has access to a connection object. That connection object has our server socket. So we'll call that, and then we'll call .accept here. All right, perfect. So now we have essentially allowed someone to connect. So what we want to do is we want to send some information over to that player who just connected. Really, whoever's running the server has the power to tweak a lot of aspects of gameplay for every single person that is connected to the server. They can change the size of the game room. They can change how long a round lasts, the total number of players, the frames per second that should run on a client. And these are all of the constants that we defined on the server end here. So let's send all of those constants over to the player that just connected. We should note, though, that all of these values, so if we look up here, all of these values are integers. So in order to encode them and send them, what we'll have to do first is cast them to strings so that we can encode and send. And recall, we're going to use our fixed length headers here to send everything. I think for this point in the game, it might be a little overkill, but it's going to be super helpful for us moving forward to kind of just get into this habit of using the fixed length headers. So I'm just going to go ahead and do it here anyway right now. So let's send, once the player has connected, let's send over some information. So we'll say send the current game configuration values over to the client. All right, so the first thing that we'll do is we'll do the room size. So we're going to get a header, and we're going to get the length of room size, but room size is an integer, so we can't do that. So we got to first cast it to a string. So we'll get room size. So what do I mean by that? Well, if the room size is 700, what is the length of 700? Well, it's an integer. It doesn't have a length. But what is the length of 700 as a string? The length is 3. And so that's going to work nicely for us. Of course, that is now an integer, and we really want that value to be a string, because what we're going to do is we are going to append a bunch of white space to it as long as it's not the correct header length. And so it's not the correct header length right now if it's 700. It's only 3 characters long. We need it to be 10 characters long. That's our defined header length. So we'll say while the length of our header, and we can do this now because header now is a string, so we can take the length function of it, is less than our header length. And our header length is stored in our connection object, so self.connection.header length. All right, so what are we going to do here? Well, we'll take our header and we will simply add a white space to it. So now we'll build up our header. So instead of maybe saying 700, it will say 700 with, that's 3, 4, 5, 6, 7, 8, 9, 10 spaces. So that's what it's going to turn into. And I'll leave that as a little comment right there. All right, I'll just put that as a comment. So that's what our header is going to turn into. Now that our header is the correct length, let's send it over to the player that just connected. So we need their socket. Well, we have that socket right here. So it's within this method. So we can say player socket dot send. The first thing we'll send is the header. So header, and we have to encode it. It's a string, so we can encode it right now. So we'll say dot encode, and we'll pass in an encoder. Our encoder is stored within our connection object. So self.connection.encoder. Awesome. Now that will say, hey, we have an incoming message, and that message is going to be, I don't know, however big it is. So let's send it over. Oh, this is wrong. This is wrong. This would be 3, right? 700 has a length of 3. So the header is 3, and then this would turn into 3 with, an accurate amount of spaces in it. I'm actually just going to get rid of that comment because I think that's a very confusing comment right there. Now let's send over the actual information. So we'll do socket.send, and we want to send over the room size, but we have to make sure it's a string so we can encode it. So we'll call str room underscore size, and then we'll call dot encode, and we'll pass in our encoder, which is found in our connection object. So self.connection.encoder. All right, so that is kind of like the process for sending these initial game configuration values over. So what I'm going to do is I'm actually going to copy it. I'm going to copy this whole thing, and we're going to paste it, I think, 3 more times, because we're going to send 4 pieces of information here right now. So we'll do 1, 2. All right, so here's our second one. Our second piece of information that we'll send over, I'm just going to change room size to round time. And we'll change room size to round time right here. And then we'll do another one. All right, bring this to the correct location. The next thing that we'll send over is our frames per second, FPS. And then our last thing that we'll send over is our total players. So the total number of players we expect. Total players. All right, perfect. We're not going to send over the player size because what we'll do is we'll send that over when we actually create a player here. So why don't we actually work on actually writing that player now? So on the server end, right, the player's connected. So we've accepted someone. We've just sent them all of the current game configuration values. The next thing that we have to do is we have to create a player for them. So we'll say create a new player object for the connected client. So we'll say, hey, we're creating a new player. So I'm going to take my game's player count attribute, and we'll add 1 to it. We'll increment that, and then we'll create a new player object. So we'll say player is equal to a player object. And what does a player object need to be initialized over here on the server? All it needs is a number. Well, which number is it? Is it player 1, player 2, player 3, player 4? Well, thankfully, we've got a attribute here in the game that we can just pass in. So we'll say pass in self.playerCount. So that first player that we create will, in fact, be player number 1. All right, now, since we made a new player, we've got a couple of lists, I think, in the game object that are going to help us keep track of things. If we just scroll up, we look, we've got a player objects list. We should append our player to this, and we have a player sockets list. We'll append this player's socket to that list as well. So we'll come over here and we'll say self.player_objects.append, and we'll append the player object that we just created, and then we'll do self.player_sockets.append, and we'll take this current player socket and append it into this list. And then I'm going to put some visual feedback on the server. I'll say print, and we'll do an F string, and I'll say new player joining from, and then I'll put their player address, so their IP address. And that player address is something that we grabbed right here when we accepted that connection. And we'll come down here. I'll finish formatting it. I'll do ... and I'll actually indicate the total number of players as well. So I'll say total players is, and then in here we'll put our player count. So self.player count. So when the first person joins, it'll say, hey, new player joining from, it'll give their IP address, and it'll say total players 1. I think that's going to be some needed visual feedback on the server end. So this is all happening if only when our player count is less than total number of players. So what do we want to do if it's not? So like when this while loop ends, let's break out of this while loop here. So we'll break out of the while loop and we'll just say maximum number of players reached, no longer accepting new players. So let's just print that to the server. So we'll print and we'll say f string. We'll do an f string here and we'll say total players, whatever our total players. So if it's 4, it'll say 4 players in game, no longer accepting new players, ... All right, so that'll just let us know that we are, in fact, ready to go. All right, so I think for right now, our connect player method looks pretty darn good. We're sending a lot of information over to the client at the start of the game about how the Pygame should be configured. I'm going to save this, Control S to save, and let's head over to the client now. And let's actually see if we can quickly receive some of this information. So I'm going to scroll down. And where are we receiving this information? We're receiving the information right after we make a connection. So we're creating a connection object here. When we create that connection object at the start of our actual code, we have no connection object right now. So we actually have to write this connection object. So that's easy enough. Let's write this connection object quickly. So we'll put some information in here, like attributes. We'll do self.encoder again, and we'll set the encoders to be the same. So it'll be UTF-8. And let's set a header size. So we'll say self.header length is equal to 10. And then let's create a socket and connect. So as soon as we create the my connection object, it will create a socket for us and connect to the server. So we'll do self.player socket is equal to socket.socket. And inside of here, we'll call socket.af_inet. And we'll do socket.sock_stream. And now we'll connect. So self.player socket.connect. And where are we connecting to? We are connecting to our destination IP and our destination _ port. Perfect. So we're going to go back down now to the bottom of our code. But no, when we create our connection object, we are connecting to the server right here. So when we connect to the server, what is the server going to do? Well, it's going to accept our connection, and then it's sending us over 4 pieces of information. So we got to grab those. But before we grab the information, what we really have to do is we have to grab the headers, right? We got to grab the header, which is really going to tell us how big the next packet is that's coming in. So I'll call that my packet size. So if we look here, we're going to do this 4 times. And so let's kind of walk through it once, and then maybe we'll just sort of copy and paste here. So I'm going to get a packet size, so packet size from the server. So I have to access the socket. The socket is stored in the connection object. So my connection dot player socket. All right, and we're going to want to receive from the server. Now, we have to specify how big the incoming packet is. Well, it's a header, so we have my connection dot header length. All right, that'll specify how big that is. And now what we want to do is we want to decode this. This is going to be a bytes object. We've just received it, so we'll decode it. Decode, and we'll pass in my connection dot encoder to get our UTF-8 encoder. I mean, we could just write UTF in there all the time, but if we want to change it, then that becomes a huge pain. So I'm going to stick to this method here. Now that we have this packet size, it tells us how large the next incoming packet is. That next incoming packet, if we come look at our server, it is going to be the room size, so how big our game window should be. So I'm going to call this room _ size is equal to my connection dot player socket dot receive RECV. Now, how big is this packet going to be? Well, it's going to be our packet size. That's how large. This is a string, however, because we've decoded it. When it decodes, it's going to be a string. So we're going to cast it into an integer so that we can actually use it here. And then we'll call .decode, and we'll use our my connection dot encoder to decode. Perfect. But again, we have decoded a byte object, so this whole thing is going to be a string. However, you look like our room size, our window width and window height, we need these to be integers. So let's just cast this whole thing now to an int. All right, and that is going to be the process. So let's copy this whole thing. And we said we're going to send and receive 4 things. So let's paste. There's our second, our third, and our fourth. And all we have to do is kind of just change the names. So what's the second thing we get? The second thing we get from the server is our round time. So we're going to get a packet size that indicates how large the next incoming packet is. And that next incoming packet is not room size. It is round time. All right, and then we're going to get a packet size from a header, and it's going to tell us how big the next packet is. That next packet is not room size. That next packet is our frames per second. So we'll call this FPS. And then we're going to get another packet size from a header that tells us how big the incoming packet is. That next packet is not room size. It is the total number of players. So we'll say total players here. Awesome. Now, I do think, maybe it's a little overkill to use fixed length headers here to just send over some integers, but I want us to get into the habit of using the fixed length headers to see how it works, because we're going to use them, extensively throughout these videos here. So the last thing that I'm going to do is I've hard coded a lot of Pygame values, so let's change them so that they're dynamic. So the window width, I'm going to set it to be the room size that I received from the server. Same thing with the window height, so room size. Same thing with round time. We'll set it to round time, the round time that I receive. Same thing with FPS. Let's change our FPS from 30 to whatever value we get from the server. And then lastly, don't forget, I've got total players here. If we scroll down, when we created our game object, we required a total number of players. We hard-coded that as 4, so we're going to take that out and we'll just write total players here. So now if I run, you see our server, what are these stats right here? Room size of 400. So let's just see. If I run my server, oh, we have an attribute here. It says server socket. None type has no attribute server socket. Okay, so let's go see what this error is that I have here on my server side. This is on line 71. 71. Self.connection.server socket. Server socket. I'm going to pause the video and debug this, and I will be right back. Oh my goodness. What a silly mistake. I made this mistake. You hopefully did not make this mistake. You probably were watching one of the last videos going, what the heck is this guy doing? Where I'm defining my classes, right? I got class player, I have class game. Look what I did. I wrote def connection. It's got to be class connection. I'm so sorry about that. I was just moving really fast, and that was a silly mistake. So when you declare a class, you have to say, hey, this is a class. And then when you declare the methods, you define them. So now let's try running this now. All right, server is listening for incoming connections. Let's run the client. Let's see if we get our gameplay information correctly. Okay, so we have one last error here. It says my connection is not defined. Did you mean my connection? I did mean that. I must have spelled it wrong. So if I go down to line, this looks like it's on line 104. My connection. So I'm going to show you something interesting. Because I copy and pasted that error over and over again, I can actually hold Alt and click, and I'll get multiple cursors here. So I'll say my connection. Let's make sure we spell connection correctly here. C-O-N-N-E. C-T-I-O-N. I think that looks correct. My connection. All right, so now we've made those appropriate changes. Let's try one more time. So we'll run our server. That's just how it is. You got to debug these errors, and they happen. Even when you think you know what you're doing, small typos can get you. Header length. Oh my goodness, I have another error. I am so sorry about this, folks. So my connection.playersocket.receive.encode. Did I spell header length wrong the entire time? I did. So let's do a quick fix here. My apologies. All right, we'll save it, and let's try one last time. I'll close these out, and let's run the server. What should have been, maybe a minute to test is now turning into like 3 minutes. Apologies. All right, so there we go. No more errors. And it looks like we got some game window information from here. Let's change the game window on the server, and let's see if it changes here. So let's update this to like, I don't know, 700. So we changed the room size on the server, and so now hopefully those changes are going to be pushed over to the client. Oh, you can only have one server running at a time. Silly me. So we'll run these. All right, server is listening, and we run. Is our window going to be bigger? And it is. Awesome. So it looks like, the server, when we connect to client, the server is sending all of our gameplay configurations over to the client, and then the client is using them to adjust on their end. This is working out really perfect. So I think this is a great place to stop. We will continue building out these scripts in our next video. So I'll see you then.